for your elementary school years, and I'm not going to necessarily disagree with that. It's not a good definition. All right. Energy has a lot of things, and they'll get more into it, but work is how I transfer energy. So saying that energy is the ability to do work has problems to me. All right? But where can I can store energy in different places, different ways. All right? If I have measured off the top of the table the marker, it has potential energy. All right? It has potential energy because it's a mass in a gravity field. All right? And potential energy of gravity potential energy is mgh, and they call it Y. All right? I could also, and how do I know that there's energy there? Close your eyes. Close your eyes. What'd I do? How do you know? You heard it. That was sound. I used some of the energy of that to make sound. Which you heard. Yes? So obviously there was energy in it. All right? Now, if I took the marker and you weren't looking because you weren't paying attention to me while I'm lecturing and I threw it and hit you in the face, could it hurt? Depends on how hard I threw it. Right? So what did I do? I transferred energy to you. How do you know? Because energy hurts you. The more energy there is, the more it hurts. That's one way of looking at it. Right? And there is energy of motion. That's kinetic energy. And that's 1/2 mv squared. This is what they have in there. Okay? And then work, by definition, work is going to be force through a displacement. And this is my before side. There is a fundamental concept on those big ideas things called conservation. All right? Conservation just means before equals after. In chemistry, what's one of the conservations that you did? Conservation of mass. And how did you use conservation of mass?
The left side of the equation equals the right side, so you can't.
The left side of the equation, in terms of what equals the right side of the equation? Okay, how about number of atoms? Didn't you do it with number of atoms? Right? If you had 12 carbon atoms on the left side, you had to have 12 carbon atoms on the right side, 16 oxygens, 12 fluorines, whatever it was. You counted up number of atoms, and they told you that was conservation of mass. They lied to you. Oh, if I take methane, that's CH4, plus oxygen, and I burn it, I get CO2 and H2O. And you're going to balance the number of carbons, oxygen, and hydrogens on the left side with the number of carbons, oxygen, and hydrogen on the right side. And you're going to tell me it was conservation of mass, and it's a lie. Because the right side will weigh a lot more than the left side. Same number of atoms, but the mass is definitely not conserved. What is Einstein's most famous equation? E, energy, equals mass times c squared. And the amount of mass that's missing between the right and the left, in your case, the left and the right, but you're backwards to me, so, right? Okay, the amount of mass that's missing is equal to the heat energy you have divided by c squared. So when they say conservation of mass, do you understand that they lied to you? It was a nice lie, but they still lied. All right? We really do in physics. Actually, in the next 6 weeks, all three of us, Mr. Sharkey, Mr. Long, and I, are going to lie to you.
Why didn't you lie?
Because we're in physics land. And we want to do this math ways nice. If you take AP3 and we do the calculus parts of physics, I'll tell you the truth. But for now, it will be a lie. I'm just not going to tell you it's a lie. All right? So this is the before side. You realize then I would have these same three things on the after side? Okay, and conservation says they're going to be conserved. This is conservation of energy. What does mathematically fair mean?
What you do to one side, you have to do to the
Whatever
other.
you do to one side, you do to the other side. Or, because what's going to happen is I'm going to say this is a constant. Whatever I do to one term, I would have to do to all terms. Okay? So I'm going to divide all of my terms by volume. And if I divide a constant by a constant, what do I get? I still get a constant. If I didn't know the first constant and I divide by something, I get a new constant, but if I didn't know the first one, who cares? It's still a constant. Yes? So it's still constant. All right, what is mass over volume?
Density.
Density! Yay! So I get to replace this with density. Oh. Okay. Distance has units of what? Meters. Volume has units of
Millimeters.
meters cubed. What would be meters over meters cubed?
Meters to the -2.
Wouldn't it be just 1 over meter squared?
Yeah.
Meter squared is a unit of area. So I could get rid of this and put area. But what is force over area? Pressure. Yes? I'll wait, but I mean, my weight's not going to change. I'm on a diet, but it really doesn't work well. No? We can go on. Okay. Rho GH, 1/2 rho V squared plus P1. This is my initial. Is going to equal the same things on the other side. This is Bernoulli's principle. This is Bernoulli's equation. Bernoulli's equation comes from conservation of energy. And that's what we look like. All right? So this is what we get. It's just more understandable if I show you what it means, of where it comes from, and we get that part. All right. So what does Bernoulli's principle give you? Okay. So here I have my airplane wing. Okay. The air starts at this level, ends at this level. It doesn't go up or down, so this is gone. Okay? But think about this. For the air that goes on the bottom of the wing, it just goes straight across. Has a certain pressure. For the air that goes, doesn't it go faster? It goes to a greater distance. All right, this is going to be equal to constant. If it goes faster, doesn't this number go up? If this number goes up, what does this number do? Goes down. That means the pressure on the top of the wing is less than the pressure on the bottom of the wing. And what's pressure times area? Force. So that means the force on the bottom of the wing is more than the force on the top of the wing. What's the plane do? Flies. Kind of cool. And if you go to an airport and you watch like a 777 or the Airbus from France, okay, those things weigh like hundreds of thousands of tons, and they actually get into the air. That's like unbelievable. I'm a physicist, and it's unbelievable to me. Which is why when I fly, I just don't worry about it. He says, okay, we're good. And I really like flying, so that's what it gets. Some of the pressure, surfaces, that's all of what that means. All right? Now, water's gonna come out of here, right? Okay. Just like I can do on my original here, where, how fast does this hit? Well, doesn't it fall?
Yes.
Okay, so I've got some mgh, and all of that energy goes into kinetic energy, v squared, and so my v is the square root of 2gh. All right? Masses would cancel. We could do all of those things. Well, I can divide both of these by volume. And once again, get a rho. And the speed of the water coming out of here doesn't matter on the fluid. We're doing ideal fluids, right? Because if this was honey, it wouldn't be true. All right? But the speed of the water coming out of here is relative to the height above it only. Well, it also matters what planet you're on, but we assume Earth, right? That velocity is the square root of 2gh. And that is Torricelli's theorem. It's just a version of Bernoulli's. So we go through. Why do they cancel out the two pressures? Here and here. We're looking at this problem.
Because they
Equal.
Pressure at 1 and the pressure at 2. They're both open to the air. Right? There's atmospheric pressure there, there's atmospheric pressure here. And the difference between the atmospheric pressure is like, who cares? Okay? We consider the height of this room that's the same. Right? It's gonna be this. Let's say for extra credit, you need to find out, I don't know. What's the bank tower in Fort Worth that got nailed by the tornado and now it's an apartment building? But you know what I mean? One of the tall buildings in Fort Worth, right? If we had extra credit, it says, okay, I am going to give you this very expensive barometer. It measures air pressure, right? And I want you to find out the height of the building. How could you use a barometer to find out the height of the building? Well, one way is you measure the pressure at the bottom, right? Go up to the top of the building and measure the pressure. And the difference between those pressures is rho GH. Because of the height of any fluid, right? The pressure is due to the height of the fluid, right? That's the fluid's way of doing it. You could also take the barometer off the top and drop it, time how long it takes to smash at the bottom, and D is equal to 1 FAQ squared. Or if you're really inventive, you can go to the maintenance guy who runs the building and say, I have this beautiful barometer, I'll give it to you if you tell me the height of the building. Hopefully work. Some are more physically oriented than others. You know, but if you're a businessman, the third one really works. All right, so the V squared ends up as 2g delta H. Process that we've done, fluids, and Bernoulli's equation, so that's really the end. So we're going to stop there.